My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 400. In this lecture, I will continue my discussion on building decision tree, splitting numerical features. Since we learned how to construct decision tree, the most important step in construction of decision tree is splitting the node. For all these, we need information gain, isn't it? In information gain, we typically use entropy. Instead of using entropy, we can choose Gini impurity, because as we mentioned earlier, Gini impurity is computationally efficient as compared to entropy, but it has same behavior as entropy. Lot of state of the art libraries actually use Gini impurity and information gain instead of using entropy and information gain. Now, a big problem is, till now we have only seen discrete random variable or categorical features. So we have only seen categorical features. What happens if I have feature? Let's take a feature like this. Let me say, let's call it as F1. This is my feature 1. This is, let me call this feature as my F1. F1 is my feature. What are the values of this feature? 2.2, 2.6. Yes. Let me choose another color. Yes. This is, let me say, 2.2, 2.6, 3.5, 3.8, 4.6, 5.3. This is my feature F1, isn't it? Let's assume my F1 is numerical feature. By numerical, it means it is an integer feature or it could be a real valued feature, isn't it? Just we are assuming F1 is a numerical feature. Numerical feature means it can be an integer feature or real valued feature, either of them. So let's assume I have numerical feature F1 and of course I have other feature Y which has got values zeros and ones. Now, how do I compute entropy? Because if I am trying to split based on categorical variables, for example, if I feature F2, let me say I have feature F2 which has 3 categories. If it has 3 categories, how can I split? This is simple way, isn't it? If I have categorical feature with 3 categories, I can split like this. But what if I have real valued feature? Here all these are real valued features or numerical features. How do I split it? Because there are many values here. Here all values. What are the values? You have 2.22, 5.3 means there are all these values are distinct. I can break it into, how many values are there? 6 values. I can break it into these 6 values. Just I am writing these values: 2.2, 2.6, 3.5, 3.8, 4.6. Just I am keeping all these values here, isn't it? This is like useless. Is it advisable? It's useless. It's useless, isn't it? Because only one point everywhere in each class. In each class, you have only one point. So, what is the way around it? What is the solution for it? For categorical variable, life is simple. For numerical features, we do a simple hack. First thing that we do is sort the numerical features. What you have to do? You have to sort the numerical features, because numbers can be sorted. So we sort the numerical feature, let's say in ascending order. This is already sorted. I wrote it in ascending order. Then I say, when if my condition is like this, my decision tree condition is F1 less than 2.2. This is one possible condition. The other possible conditions, what are other possible conditions? F1 less than 2.6, 3.5, 3.8, 4.6, 5.3, isn't it? There are 6 possible values. Suppose if I say F1 less than 3.5. If I say yes, yes means what? How many possible values for less than 3.5 means this is D1. This is first data set. This is D2. Isn't it? How many values? 2. 2 points here. 1, 2, 3, 4. I will get 4 points. If I say yes for the first 2 points. If I say yes, what will I get? These first 2 points. Isn't it? Will come here, and rest of the 4 points. These 4 points will go here. Isn't it? Will come this. So what if in my decision tree, instead of categorical feature values, what if I have numerical less than equal to features? This is one possibility, but now how do you decide? Because see, if I have n data points, and let's assume all of them are distinct, I can break them up. I can break it up. How can I break? I can break it up like this into 2 data sets. How can I break it up? There are different possibilities. Just see, this is one possibility. In that case, this is D1. This one is D2. And another possibility. What is another possibility? This is one data set. This is another data set. In similar manner, I can break it like this, isn't it? So I can have at most, I can break it up like this. So I can have at most n possible variations. I can say n possible variations here. Let's assume if some value is repeat, I can have less than n possibilities. If some value is repeated, I can have less than n possibilities. So when you have numerical features, for each feature, let's feature value less than threshold 1. What is threshold 1? This is threshold 1. What is this? This is threshold 1, threshold 2. This is E1, this is E2, this is E3, this is E4, this is E5, this is E6. There are 6 possible values. I have got 6 thresholds, isn't it? Just see, F1 less than E1, F1 less than E2, there are 6, E1, E2, E3. So if there are n possible values, I can write. If there are n points, if earlier you had 6 points, therefore I wrote 6 values, E6. If there are n points, E1, E2, E3, so on, I will get En, isn't it? For you, your thresholds are nothing but these values: 2.2, 2.6, 3.5, 3.8, 4.6, 5.3. All these values are known as threshold. For every one of, if I choose F1 less than E1, just what happens? F1 less than E1. For you will have to get 2 data sets, D1, D2. I will get 2 data sets. In similar manner, F1 less than E2, I will get 2 data sets. In similar manner, so on. Fn less than En, I will get 2 data sets. So what we do for numerical features is, we will evaluate all these. Just see, we are evaluating all these. We will evaluate all these. We will check through all n possible splitting criteria, isn't it? Because there are almost n possible criteria. Like here we have 6 points, isn't it? 2.2 to 3, 5.3, 6 points. Therefore you have 6 criteria. So we check through all possible criteria and we pick the one which gives you maximum information gain. This is quite time consuming actually. If you think about it, it is non-trivial and it takes some time, because for every value here we have to cut the data into D1 and D2. Let's assume F1 less than E3 less than E3, D1, D2 has good information gain. Let's say this particular thing has good information gain. This has the best information gain. Now you compare it with, suppose if you have a bunch of features, let's assume you have 2 features. Let me say you have 2 features. Suppose you have feature F1 and feature F2. Let me say I have 2 features. This is my feature F1, this is my feature F2. F1 is numerical feature and F2 is categorical feature. For categorical features, you will get information gain directly. For numerical features, you pick the best information gain in all the possible criteria. The best one the maximum information gain. Now again compare both of them. What can I compare? What can I compare here? I can compare numerical feature information gain with the categorical feature information gain. I can compare, isn't it? This is how we will do it. Handling numerical features somewhat time consuming. There are hacks around it. There are very, very nice computational tools people build to make it work, especially for numerical features. Just go through it. If you have any difficulty, please keep a comment. Thank you very much.